This video clips will cover the security allocation, the developed version of the Marquis optimal portfolio with the Sharpe ratio. The last video clips, we have found the Marquis full variance model, the combinations of each security between securities on the equal weights, and then what is the combination boarded, the variance covariance is target return under the target return, and then we drew this efficient frontal line here, the combination of the mean and standard deviation, and definitely above this line upper line dominate the lower line, or between this line. Also the above line is the efficient, right? Efficient means once the investors get a more the risk acceptance, they definitely require higher expected rate of return, right? So yeah, that we found here the portfolio weights. Now here, this model will find what is the optimal portfolio, or where the investors can satisfy with this with the portfolio investment, or what is the minimum the variances where the investors can avoid some riskiness, right? So first we'll find the minimum risk portfolio, and we'll also define the optimal risk portfolio, right? So let's get started. Here first, the board of the covariance matrix and the portfolio risk premium and standard deviation and Sharpe ratio. We'll use the Sharpe ratio to find the maximum performance. Sharpe ratio, how to calculate it? Right, the excess return divided by standard deviation, right? If the Sharpe ratio is high, then the slope of this the model, the capital allocation line is the steeper, right? Which means this x-axis, once we increase x-axis, but now the y-axis increase more. So we are using a little different model. Once we practice this, how to calculate border covariance matrix, we'll directly calculate this portfolio variances from this the covariance matrix. Okay, so let's get. This case we have now U.S., U.K., France, German, and Australia, and Japan and Canada, and we need to collect this excess return from the security and analyst. Then let's find this portfolio weight, right? Portfolio weight. Here, let's put any kind of random number, right? Random number, but that must be all. The sum of this must be equal to 1, right? So any number. Let's put just 20%. Okay, 0, 0, right? So what you're going to do here is to calculate these variances, portfolio variances here, and then we calculate the standard deviation of portfolio and the Sharpe ratio. Okay, so let's get this number. So we'll use this equation directly. As you can see here, we have the same component, which is a weight, right? So we'll take the weight out. We'll also take that weight, right? So here, how to calculate this? First, you need to calculate. We need to get this weight, right? Again, equal this weight times now sum product of this weight, comma, and what do we need? Right, this one and here. Right, this is sum of these covariances matrix and the weight, right? But we want to be very efficient again. I want to fix Also, I want to fix the column so that, oops, okay, so that when I drag to the right, I calculate all. So again, this is not the optimal, or even is not the minimum variance of the weight yet, but we need to complete this model first, and then we'll use a server to find these minimum variances or the optimal variances. So let's go to the risk premium. How to calculate risk premium? Right, same process. Some product of this what? Yeah, of this weight, right? Comma. And then what do we want to find? Okay, here you go. The excess return, which is risk premium, which is same. So we got this. The risk excess return or portfolio risk premium. The portfolio standard deviation, how to calculate it? Right. Once we got this, let me just sum of this all. What is this sum? Right, in the previous slide, previous exercise, this is the portfolio variances, right? And multiply, this is square root, right? Or just you can use the square root. Anyway, you got this same. So the standard deviation, if we invest 20%, 20%, 20% of this, the weight of these the securities, then we can expect the 16.75% standard deviation. Now, the Sharpe ratio. Why Sharpe ratio is so important? Sharpe ratio is calculated excess return over the standard deviation, right? Excess return is the y-axis, and x-axis is the standard deviation. That shows the performance. If your client is the very rational, just normal, average, the investors, they are willing to take the risk if this risk produce higher rate of return than the increase in the standard deviation, right? So that's why steeper is better. Then how to calculate this? Now, just expected excess return or the risk premium divided by standard deviation. So this is Sharpe ratio. Our goal is to maximize this, the Sharpe ratio, right? But first, let's find this minimum variance of the portfolios. Minimum variance, that means this standard deviation is minimum regardless of this Sharpe ratio performance. So minimum variance portfolio, how to find it? So go to the data and server. Okay, here set objective of the standard deviation. Standard deviation. What is standard deviation? Okay, there we go. This is standard deviation. Minimum. We want to make this standard deviation minimum, right? By changing the cell of all these weights, right? And then your Excel, I will find this, the optimal weight that reach to the minimum standard deviation. We need to have like constant 1, but we do not have other constants. I'm trying to make other the cases that we allow the short sell or borrowings, right? So we allow this short sell of each the securities, right? That's why here constraint is only the B24, which is the total weight of the portfolio, is just 1. Then that's totally fine, right? And then let's just serve. Okay, then do you see here? Now, this is a weight of the US, UK, and France, all this. So once you got it, just copy and paste on this minimum variance portfolio, where what is the risk premium, right? 3.8%. What is the standard deviation? 11%, right? We just copy and paste here, right? And the portfolio, the Sharpe ratio is 33%, right? But we'll compare the Sharpe ratios into the risk premium on capital allocation line. We'll draw this, right? So this is the minimum the portfolio, because standard deviation, when you compare, when you put the different setup like risk premium, if we set the risk premium 3.5%, for example, on the server, I want to set this not minimum but the value of this value. For example, risk premium, now the value of 3.5% risk-free premium. Then when I change this, the weight of the portfolio, then what can be the result, right? And the serve, okay, then, okay, so here we go, 11 point, slightly different, but here, this is the weight, right? This is the weight on the target rate of expected the excess return or risk premium, right? Likewise, you can build all these cases, right? But again, what we found here is that here, right? This point, the minimum cases when the standard deviation 11, that is the minimum. So as you can see here, the standard deviation of portfolio, this 11.32% is a minimum, right? It's minimum. So under this, we found the portfolio, the Sharpe ratios, and then risk premium, right? And the combination of risk premium and the standard deviation is this line, which is efficient frontier line, right? Now, let's move to the optimal risk portfolio. Optimal risk portfolio. Then how do I find the optimal risk portfolio? Now we'll change this conditions on the data server. Where's the objective now? Yes, this objective must be now the Sharpe ratio. Highest the slope, that means the under this the efficient frontier line, right? So let's use this, and maximum by changing the variable, which is the weight, and same the subject to the constraint of the total portfolio, the 100%, and then serve. Okay, so we found, the maximum Sharpe ratio to be able to achieve is 41%. 41%, here we go, 41%. With the 13% standard deviation and 5.64% the expected the excess return, or risk premium, right? Why this line is so important? Why this point is so important? This is the only the combination of the standard deviation, the Sharpe ratios, standard deviation and risk premium, that satisfy the efficient frontier line, the possible efficient frontier line. So we'll draw the capital asset allocation line here, on here, to find the tangent point, So how to draw? We need to calculate now the risk premium on the capital allocation line, risk premium on capital allocation line. So now how to calculate it? So do you guys remember here, the risky portfolio, the risk premium is equal to the Sharpe ratio times the portfolio standard deviation. How? The excess return or risk premium of portfolio divided by the portfolio standard deviation is the Sharpe ratio. Is that right? Yes. So we can just rearrange this portfolio to get this risk premium on the capital asset allocation line that has the same Sharpe ratio, because the shape of the slope are the same on this capital allocation line. So here we calculate just what's the standard deviation in this case, right? When the risk premium is 0.35%. But here, the Sharpe ratio we share is now, that's slope. We want to fix this. And so that we got the risk premium with this, the Sharpe ratio, which is the same slope, right? And then let's just drag it to the right. So all this combination now, the Sharpe ratios with this risk premium on this capital allocation line now has on the same allocation line, capital asset allocation line, capital allocation line. So as you can see here, we just finished the drawing. So here we try to find, this is a minimum variance point, but here we found the tangent point that is the optimal, the portfolio, where we found here the maximum Sharpe ratio with the standard deviation and the risk premium 5% and 30% standard deviation. Okay, so let's finish up this exercise, and then we'll see on the index model later. You guys, bye-bye.